This week at NASA. NASA astronaut Chris Cassidy and his Expedition 3536 crewmates have completed final training for their upcoming mission to the International Space Station. Conducted at the Gagarin Cosmonaut Training Center in Star City outside Moscow, this qualification training all but clears the way for Cassidy and Pavel Vinogradov and Alexander Mazurkin of the Russian Federal Space Agency to launch to the orbiting laboratory later this month aboard a Soyuz spacecraft.
For the first ever for-orbit rendezvous.
The trio also took questions from news media at Star City in one of several traditional pre-launch activities. Also included was a visit to Moscow's Red Square, where the crew and its backups laid flowers at the Kremlin Wall and paid tribute to iconic Russian space heroes. Cassidy, Vinogradov, and Mazurkin are scheduled to launch to the International Space Station from Kazakhstan on March 29th local time. By that March 29th milestone, the SpaceX Dragon capsule, now berthed at the International Space Station, is scheduled to be back on Earth, having safely splashed down in the Pacific Ocean 4 days earlier on March 25th. In a satellite interview conducted the morning of Dragon's March 1st launch from Cape Canaveral Air Force Station, NASA Deputy Administrator Lori Garver spoke about some of the science experiments Dragon's brought up to the world's only laboratory in microgravity.
Experiments on materials research, combustion, life sciences, as well as making solar cells and semiconductor chips more efficiently are all benefits that we are working on this mission.
Inside the Kennedy Space Center's iconic vehicle assembly building, crane operators, technicians, and engineers practice lifting and placing a 6-ton replica of the Launch Abort System's escape rocket atop a mock-up of the Orion capsule. Although the Space Launch System flight is still a few years away, practicing stacking procedures now will help the team perfect the task ahead of mission-critical operations. The Launch Abort System has solid-fueled engines that can lift Orion and its crew away from the rocket in the unlikely event a booster fails during initial launch. A test flight in 2010 saw the LAS produce 500,000 pounds of thrust, about the same as the Titan II rockets that launched Gemini spacecraft into orbit. A newly released image taken by NASA's Cassini spacecraft orbiting Saturn shows a distant world visible through the planet's rings. The bright dot just above and to the right of the image's center is none other than Earth's twin planet, Venus. This view looks toward the non-illuminated side of the rings from about 17 degrees below the ring plane. The image was taken in visible light last November by Cassini's wide-angle camera. Scientists from Ames Research Center, the Jet Propulsion Laboratory, and the Goddard Space Flight Center returned to the rugged terrain of California's Death Valley National Park for NASA's second annual Mars Fest. The event, held in a vast area of wind-swept sand dunes and other Mars-like terrain, gave park visitors a chance to see how NASA studies exotic environments similar to those on the Red Planet. Sample items and materials used on the Mars Curiosity rover were displayed, and JPL scientists demonstrated how the rover's Chemin X-ray diffraction instrument, developed at Ames, is currently analyzing drilling samples on the Martian surface. NASA researchers from the Langley, Glenn, and Dryden Flight Research Centers are teaming up to study the effects of alternate biofuel on engine performance, emissions, and aircraft-generated contrails. Cruising at altitudes up to 40,000 feet, the agency's DC-8 flying laboratory is followed at varying distances by an instrumented NASA HU-25 Falcon aircraft.
Our instrument suite will measure the NOx components, carbon monoxide, carbon dioxide, plus a lot of different aspects of the particles that come out of the aircraft.
The project, called Access for Alternative Fuel Effects on Contrails and Cruise Emissions, will provide important data for NASA's continuing effort to make air travel not only safer, but cleaner.
Many of us have never heard a sonic boom. It's a noise created by shock waves from a supersonic jet as it travels through the air faster than the speed of sound.
If you were listening to the Concorde, which stopped flying in 2003, you would definitely know that it had passed overhead, and you might wonder if a car had backfired just outside.
How much noise is too much noise? That's one question NASA researchers like Jonathan Rathsam are trying to answer as NASA and industry work to develop a supersonic passenger jet that is quiet enough to fly over land. To quantify objectionable noise levels, NASA invites test subjects, regular people from the community, to listen to sounds similar to aircraft sonic booms. The subjects sit in what looks like a living room at NASA's Langley Research Center.
We do a lot of tests for not only supersonic but subsonic, etc., where we have people come in, listen to sounds, and tell us how annoying they think the sounds are, and this will then impact future designs of aircraft.
Two of the outside walls of the room contain subwoofers and mid-range speakers, 52 of each. They create synthesized booms. 7 satellite speakers and a subwoofer inside the room mimic rattle sounds.
The subjects are asked to place an X on a scale corresponding to their annoyance. The very low end of the scale says not at all annoyed, and the high end of the scale says extremely annoyed.
The goal of the research is to come up with acceptable sonic boom noise standards that regulators and designers can use to develop supersonic jets that could fly anywhere, not just over water like previous supersonic airliners.
Aquarius, NASA's first satellite instrument built to measure the concentration of salt at the ocean's surface, now has just over a year of data under its belt. Data collected from December 2011 to December 2012 show a variety of salinity patterns, from a very salty patch in the middle of the Atlantic Ocean to pools of less salty water in the Pacific. By measuring ocean salinity from space, Aquarius is providing new insights into how fresh water moves between the ocean and the atmosphere and how that influences ocean circulation, weather, and climate around the world. Launched in June 2011, Aquarius is managed by the Goddard Space Flight Center in collaboration with the Space Agency of Argentina. Counselors from Hampton Roads area middle schools attended an engineering workshop co-hosted by Langley Research Center. The group received tips and information from Langley STEM professionals about math courses, internship programs, and other opportunities they could share with students interested in pursuing STEM careers.
I'm very excited to be here because I feel like NASA can be the catalyst to communicate to our educators what it is that they need to know to help encourage our students to go into these STEM careers.
I am Marissa Hines, and I am a mobility systems engineer here at the Jet Propulsion Laboratory. I had an opportunity to come on to the Mars Science Laboratory mission about 2 years before we launched, and I came on as part of the cruise operations team. So I was testing the attitude control system as a system engineer, and there was an opportunity to come work on the surface side of the mission. I get to work with the rover and watch it drive around the Mars yard and help understand and develop some of that new capability. It's pretty exciting to know that that's going to be used on Mars to further science. There's a little bit of development going on. So there are certain capabilities that the rover doesn't have yet on the surface. We use this rover, Maggie, to test any of those new capabilities in the software. I think because of my personality and because of how I was supported by the women in my life growing up, I've never really felt any real challenges when it came to the idea of there being fewer women in certain fields or in the field that I chose to pursue. And I certainly see a change in that happening as I see more women coming into the science and technology fields.
4, 3, 2, 1, 0, and liftoff of Endeavour.
On March 11, 2008, Space Shuttle Endeavour rose skyward from Kennedy Space Center on STS-123, an assembly flight to the International Space Station.
Set up your head, Rick. That's awesome.
Delivered to the station was Kibo, the Japanese experiment module, and the Canadian Special Purpose Dexterous Manipulator, or Dexter, robotics system. The mission also facilitated a change of station crew members, delivering NASA astronaut Garrett Reisman and returning to Earth with European Space Agency astronaut Leopold Ahartz. And that's This Week at NASA. For more on these and other stories, or to follow us on Foursquare, Facebook, and other social media, log on to www.nasa.gov.